is doing some really remarkable work at the moment. I'd like you to welcome her in the normal way. And over to Jeanne.
Thanks, it's nice to be here. I've done a lot of thinking about the building type of the tall building, especially leading up to this conference. And I was noticing that there's a lot of advancements going on in the building type in terms of exceeded heights, lots of different types of people doing tall buildings, and some environmental approaches. But altogether, I feel like there's a bit of stagnation in the tall building type, and I just wonder if we're doing our best right now to mine all the cultural, economic, and environment, especially environmental potentials that are inherent to it. Or are we just preoccupied with trying to create icons? After all, that is what all of our clients are asking us to do. Which is fine, except for, when you get so many of them, is this really enough to ignite a new kind of architecture? Or, is there maybe some potentially other areas where we could advance our thinking? So at this conference, we've seen that there's many new buildings being built, many new cities kind of rising up out of nothing, and wondering if these cities, which will be full of high-rises, as we've seen, we'll be able to have an identity other than the individual identities of the buildings. The paper kind of explores, looks at different strategies for ways to push this building type forward. But these guiding principles, I think a lot of the early architects that addressed tall buildings started to look for these guiding principles. This is Manhattan around 1855. You can see what low-rise town it was at the time. But as tall buildings started to show up, there was a concern for trying to keep light and air coming down into the streets of the city. So there was a zoning ordinance created that created this step-back skyscraper. This whole zoning ordinance was illustrated by Hugh Ferris. These are some of the drawings from that book. And it created this, it allowed the architects actually to push out of their Beaux-Arts preoccupation, which is what everybody was dealing with prior to this. And it produced some very interesting structures under these rules. This is the Daily Telegraph building, and many step-back buildings. But I think what's most interesting about it is, the actual building form of the city. When you start to get a lot of tall buildings together, we created this, in a way, a very strongly identifiable form, almost an urban icon, as opposed to a specific building icon. And so it is about creating these places and making them exciting new cities as well. I hate rules too as much as the next person, but this was a funny drawing I found from a British inventor around 1930 that kind of disregarded those zoning rules and proposed a new kind of building over Manhattan after all that effort. And this I thought it was a nice example of Jean Nouvel's building, who is taking the zoning rules that exist and just creating a form that is just a literal interpretation of the envelope, the zoning envelope. In Chicago, too, where most of the two projects I'm going to show you today are both in Chicago, and it's a particular context as well. And in Chicago, there was a lakefront zoning ordinance that created this incredible street wall you see in the image there. So no buildings were allowed to be on the lakefront except for to the west of Michigan Avenue. So just that kind of rule started to produce a certain urban space that you can see here, probably around 1915 or so. But then today, as higher buildings came and they maintained that rigor within the city. This allows for new buildings to be put into this context as well. It's not about the style of the building, it's really about just creating the space. So in the paper, I talk about these 6 points of potential areas to be further explored. I think you see it a little bit in people's work that we've seen somewhere in the conference is a touch, but I think areas that could be much further developed and fully explored. And I'm just going to talk about the top one today, site and environmental specificity. So I guess what I'm saying is I think that the way to break out of this pure fascination with only producing an icon is to actually start with a specific criteria, and then these iconographic forms can be developed from that. It's also partly because, you know, I'm working in a context in Chicago that is really already full of buildings, so it's not a blank slate. So you always think about your buildings in relation to the whole. So we're about 42 degrees latitude in Chicago. These two buildings that I'm showing are called Aqua and Solstice. We didn't name them actually, the developers did that for us. The first one, the Aqua Tower, is an 82-story tower that's currently under construction in Chicago. And like I said, we didn't really name it Aqua. We actually didn't even design it to look like water to start with, but that's what it kind of got the moniker from others. This site where Aqua is located was once really just completely full of these rail yards. I mean, the city was defined only by transportation at that time, and you can see how hard it would be to get to the lake beyond for a pedestrian. I mean, practically impossible. Today, our city this is Grant Park. The building site for Aqua is up on the top part of the slide. And you can see the building wall that I showed you of Michigan Avenue there. But the city is now defined more by a place to live and recreate and work, as opposed to being defined purely by transportation. So this site was part of a much bigger development, the Orange area. This is like 1932 WPA map of the city of Chicago that shows this terminus of the Illinois Central Rail Line. The orange, 26 acres, was to be developed as the railroads were taken out. This slide is probably about 10 years old, where you can see the kind of last remnant of a par 3 golf course that was a temporary use on the site after the railway was gone, and a couple of buildings starting to surround the park. Aqua is a building that was part of planned development, so all of it, the FAR and building heights were already defined when we came into this project. But what we proposed was actually extending the height of buildings to get more light into the surrounding areas, which was accepted by the city because this allowed, you know, they were actually very interested in how these buildings were going to work together, and granted us the extra height on the buildings. The site is really defined by 3 levels of roads. We have, you can see beyond the Pritzker Pavilion there by Frank Gehry, and the Millennium Park is beyond. But here, there are really three different roads that are one on the surface and 2 below that create this kind of pit. So in a way, it was a good advantage that we were able to put our parking down underneath that and keep the top level for pedestrians. The site shows how SMM completed this as a master plan, and the heart of it is this park in the center, 6-acre green park. But you can see how many buildings are proposed for this area. Some of these are built and some are proposed and under construction. And so really building a building in Chicago is not so much about putting this iconographic, you know, point tower that everyone will see from many views all around. It's really more knitting it into this entire fabric of tall buildings. So this shows where our site is located, and it looks very visible, but when we put in the different towers that were surrounded, it kind of got buried into the depth of the city. So in our office, we work a lot with not only digital models, but we do a lot of physical modeling, and we created a really large piece of the city in the office to start to to get a sense of how the building would be seen, not just from the upper stories, but really thinking about the places in between and how you maybe carve out views between other towers. This very crude model shows these strings that it was an idea about creating these view quarters that you wouldn't normally expect. So by bumping out the facade in certain areas, you might be able to see around a corner, especially, like I say, for these lower units in the building. And we identified 6 major views of landmarks in the city that we wanted to gain for some of the units on the lower levels, which in turn created almost a topography for this tower. So it's almost like a vertical landscape. And as we developed the tower, those first bumps remained, but they got changed in terms of shape due to all of the other functions of the tower, such as the balconies and solar shading. So we started working with this landscape, vertical landscape, and realized that the way to achieve it, again, this is in Chicago, with a very, it's a residential building, a mixed-use building, and it had a very minimal budget. So we thought, we just started looking at the materials we were going to use for the building. So with concrete and glass, basically, as our base, we found that by varying the slabs slightly on the floors, you could start to create a three-dimensional aspect. And I use this image to remind myself and other people that, we didn't really think about water when we were building the building. We weren't even really trying to imitate anything, even this rock. But what was interesting to us was more the process of erosion that you see on these rocks. This is an outcropping near Lake Michigan from wind and time that creates the final form. So we used different criteria to help shape the building, including daylight, like I said, the functional areas of the tower, and it started to take shape. So on this tower, it's 82 floors. Every floor is slightly different, and we were able to convince our client and to go ahead with this because of the strong collaboration with not only the client, but the engineer and also the contractor early on, so that we discussed how this would be made from the beginning. And we knew with the tools, in light of the tools that we have, being able to connect the drawings to the handheld devices on the site, these curves could be laid out differently, as easy as you could do repetition. Another aspect, in terms of specificity, we started to look at the glazing and find areas that did not have as much protection from the terraces, and just change the glazing type in those areas. So we had this very specific response to the glazing that is particular to what's happening with the environment, which created a pattern on the building where we changed the glass type. So the design really is about, in a way, these different layers of specificity overlapped and united to create the overall tower. These are some models that were in the sales center, and the image shows the base of the building, which will have the largest roof terrace in the city on top, about 80,000 square feet. And then it has mixed use in the base, a hotel, lobby, hotel ballroom, restaurants, and retail. And I think the overall project with all of the different parts is in the order of 1.75 million square feet. So this is just a shot from this site. The way that the curves are actually made is the builder tried out different kinds of steel and found the right grade of steel that was able to curve into the curved shape of the terrace, but then not able to be reused. So it would bounce back to a straight piece and then it could be laid in again. And this is the robotic device used for laying out the building shapes. And we're up to about, I think, 20 floors now, and it's really starting to take shape. One of the things about the Chicago market is they really are trying to build fast as well, and so the glazing needs to be coming in no more than 5 or 6 floors behind the floor slabs. All these floor slabs are taking 3 days to pour, even with the variation. The engineers here, Magnus and Clements, they really, the structural bravado is the cantilever, which go up to 12 feet in some areas. Okay, and then the other building I was going to talk about today is Solstice Tower. After doing Aqua, after designing it, I really started getting interested in how we could do more for the environmental aspect of the building, and how it could start to inform the shape as well. And this tower is, go back a second, it's located, it's a south-facing, one of its major facades is south-facing to Jackson Park, where the Museum of Science and Industry is located, and close to the lake. So there's a higher density kind of allowed along this band, and the towers are more common in that area. So here we were conceptually just using the sunlight, the angle of sunlight at our particular location on the planet, 41-degree latitude, which will give us like a certain self-shading as we carve out the building. So 72-degree angle on the facade, done in a series of tiers all the way down the facade, allows the building to take in less sunlight and reduce the cooling load. So added up, this project we're working with Arab, and they were able to help us optimize that angle by doing this study. This is in the winter, and you can see how the sunlight is penetrating into the space, and then in summer, the sunlight stays on the balconies and out of the space. So that produced this building, which is really a series of responses to these particular criteria. So in this building, one of the things we realized in Aqua was that the developer really likes the larger units toward the top. So that we just use that as a rule to create a geometry that responds to the logic of the economic condition. So this building actually grows wider as it gets taller. It's a typical construction, though, for Chicago with 2 shear walls. And what we tried to do on the shear walls was just to remove as much material as possible. So that created another rather organic pattern that is really a result of the structural analysis. So these tilted windows really reduce the amount of sunlight. This is 26 stories tall, about 143 different units inside. This shows the structural analysis of the shear wall, which really created this pattern. It's rather organic. And then view back to the city. This is an area of Chicago that's just outside the city. It's actually in the city, but it's to the south of the city near University of Chicago. So the people that will live here are either university related or people who are downsizing from their homes. So, and just to wrap up, we're interested in, we're taking a lot of these tools like the parametric modeling and trying to use the sunlight and environmental conditions to carve out shapes that respond to environment. And now we're just starting to work in India, which is a completely different climate, so it's producing another different kind of form. And this is where we're headed. Thank you.